Hello, everybody. This is Seth from DevExpress with Ayende Rahien. We're going to look at using Raven, this NoSQL craze. I sort of want to jump onto the bandwagon and see how can we use NoSQL in a sort of a good way. And so who better to ask than Ayende Rahien? He's here with us today. Ayende, how you doing?
I'm doing very well. Thank you very much.
Cool. So you not only jumped on the bandwagon, but you created your own wagon. Tell us about how you did that.
Okay, that is something that I'm going to tweet.
Cool. I like it. Tell us about your wagon and why you like it.
In 2007, I was really interested in Erlang. There is the whole pragmatic problem, learn a language a year. Mm-hmm. And not just, C# and VB, just learn different language. And I decided I really want to learn Erlang. I was at JAW, which is a conference in Denmark, and I sat with the creator of Erlang in a talk, and he was very, very impressive. I really, really dislike the Erlang syntax, mm-hmm. but the Erlang notion and ideas and VM are very, very interesting. And I'm very happy with the things that happen with C# 5.0, which allows me to basically write my own Erlang-like system with a lot of idea that I can just steal from Erlang.
You mean C# 4, right?
No, 5.0.
5.0.
4, yes. So the stuff where you can do the async and task-based stuff.
Oh, I see.
On top of that, I can bring an Erlang-like look and feel, so to speak.
I see.
Now, this is important because so I started to look at Erlang, and there isn't any substitute when you're actually talking about the language, mm-hmm. to actually writing some code in it, to actually reading real production code in order to understand how the system works.
Yeah.
So I got the Erlang book and read that, and then I looked, okay, what is the Erlang project, the Erlang open source project? That was CouchDB.
That's right.
So I sat down and I literally read the entire code base using the stupidest method possible by going through all the files in alphabetical order.
Wow. How long did that take you?
Actually, I have no idea, but as usual, everything is on the blog.
Uh-huh.
So let's see.
Let me bring that up so people can take a look at it here.
Yeah, just do it. Go to Ayende reading Erlang. Just search for Ayende reading Erlang.
Oh, I see.
And so it started in 24th of August.
There you go.
Yeah. And then we had about, oh my God. I think that it went on for something like a month. I just did this set on the code base and kept, so stop. This is Erlang. This is the reason why I don't really like that.
I see.
Because the syntax is just very, very, very nasty.
I remember looking at Erlang a while back ago, and I thought, holy cow, this is going to take a little bit to understand.
Yeah. Oh, yeah. The really fun part is that when you look at that, one of the problems that I really hate is that you can basically press Shift and run your hand on the keyboard, it will produce valid code. This is the same reason that I don't like F# very much.
Oh, I see.
Yeah. Anyway, before Amanda is going to kill me for that. So I was reading Erlang, and I was in CouchDB, and I was mainly reading CouchDB in order to, understand Erlang. But as I was reading CouchDB, I started to really get interested in CouchDB itself, and then with the way that CouchDB worked in terms of, how do you say that? the way that couching will work in terms of give me a second to remember. The way that CouchDB worked in terms of a NoSQL database.
I see.
Okay, and from that I started to look at other NoSQL databases and other NoSQL solutions. And it started, bugging around in my head, like, if you see a gun in the first act, it will fire in the third act. If I start really concentrating on something, the only way to actually get rid of that is by writing code.
That's right.
I really don't like the notion that I write my own everything. I sat down a while ago and tried to see what are the type of projects that I've written. Not client project, but things that utilities and stuff like that I actually need. And it ranged from writing my own source control system, my own build server, my own.
Wow. You're like the MacGyver of programming, then, huh? You build your own stuff.
Yeah, not necessarily a good thing, but the nice thing is that it gives you a very good, background on how to actually approach and solve problems.
I like that.
So I actually believe that I was the first one to build a NoSQL database on the .NET framework, which was RhinoDHT, which is based on the Amazon Dynamo paper. And the problem with doing stuff like that, and there's a very famous cartoon about NoSQL, and this is let me see if I can give you the link. This is the one that everyone keeps quoting.
Oh yeah, I've seen this one.
Yeah, and one of the problems with NoSQL in general is that so the original impetus for NoSQL is that Google, Amazon, people who have really, really high scalability requirements. And that is okay, but there are other alternatives for writing non-relational databases. And the reason why we want to do that, typically because the data model is drastically simpler. You can get much higher performance. You can scale better. And not necessarily, you have to scale to bazillion databases. And there are different constraints when you run on a single node, and when you're running on 10 nodes or 100 nodes.
Right.
So because of that, what I decided to do is to say, okay, I want to build, and another issue is that most of the NoSQL databases just don't run on .NET. No,
they don't.
Either they literally cannot, or they cannot even run on Windows. So I decided that this is really annoying, and I really want to be able to use the NoSQL database for my stuff.
Amen.
And yeah, so I started by writing RhinoDHT, and I realized that it is really nice. It is very easy to work with, but it is a very poor model to actually do real work with, because DHT and then DHT stands for distributed hash table. Basically, we have a dictionary, and actually being able to do something very interesting is very, very limited. You cannot do queries. You cannot do any of the things that you're used to. One of the things that I actually wanted, I want the benefits of NoSQL, but I don't want to have to pay for the cost unless I really have to.
I see.
So a typical example is, I want to be able to query, and with C# with .NET, query means that you have LINQ support. So I want to be able to run LINQ queries against my NoSQL database very, very easily. I want to have a client API that gives me as much power as in Hibernate. Basically, I wanted to have all the advantages that they have with using something as powerful as in Hibernate, but without having the limitations of NoSQL. Without having the limitation of a relational database.
Got it.
At the same time, want all the advantages of NoSQL without the disadvantages. Now, it turns out that there are really good reason for why you actually want why you have those limitations. Typically, you have those limitations because you want to run on multiple servers.
Right.
But if you don't run on multiple servers, this is a very common thing. That, you only need one server for all your stuff.
Right.
Just to give you an example, Foursquare, which has enormous scalability requirements, manage with just 4 servers for the data.
Foursquare only uses 4 servers.
4 servers for the databases.
Wow.
4 database servers. Okay. So, for the most part, you can literally just sit all the data on a single server, or you can do that using sharding with high locality. So, when you use sharding with high locality, this is something that you should speak of for like the third webcast, the scale out solutions. But basically, for a lot of the stuff, you can really use a tremendous number of features that can only work on a single machine. But because most of the NoSQL solutions focus on distribution, they don't give you those solutions.
I see.
So basically, my goal was to say, okay, I look at CouchDB, I look at MongoDB, which are the 2 common document databases in the market. Says, okay, I want what they have, but only better. So RavenDB is a 2nd generation database, and I basically looked at everything that CouchDB and MongoDB had, and everything that they didn't have, and really try to understand what are the things that they have that are good, and what are the things that they lack that I think that I can implement. On top of that, I added that, I'm a .NET developer and I understand how .NET developer thinks and the sort of things that they expect. So with RavenDB, I didn't set out to create just the database product. I set out to create a database product which has a very mature client API. I've been part of the .NET of the Hibernate project for something like 7 years now. So I have very good understanding of how to write a client-side data access components, which are in a way that has proven to be very successful. So I've took all of that and created a very tightly integrated package which give you all the power of NoSQL, and you only have to hit the limitation at very specific points.
I see.
And if you don't run into those, if you don't have this, if you don't have those points, if you don't have the specific point, if you have scale out with no locality or with very little locality, and this turned out to be a very rare scenario in most cases.
I see.
So if you don't need to do scale out, or if you have scale up with high locality, then it just works. And there's tremendous number of features that are very cool to use and do it this way.
Wow. So let me see if I follow the history. The history was that you created a dynamic hash table. Is that what it was? Sort of a key value
distributed hash table.
Oh, sorry, that's right. Distributed hash table. And what you did is you thought that's not good enough. Let me do a second try, and out comes RavenDB, a 2nd generation NoSQL database.
Yes, a 2nd generation document database.
That's right. So you've probably seen this visual guide to NoSQL systems. Where exactly does RavenDB lie in this diagram?
Just to give you some idea, this describes the CAP triangle. So we have consistency, availability, and partition tolerance. And basically, you cannot have all 3 at once. You have to have mostly because it's physically impossible.
Got it.
Think about a typical two-node system of a replicated database. So let's say that in both systems, you have the value of A is 1.
Mm-hmm.
And now if I query system A or system B, I get the same result and everything is consistent.
Right.
Now I go to server 1 and update the value of A to be 2.
Okay.
Server A updates server B. And now if I query either one of them, this is going to be consistent. So both of them will tell me that that the value of A is 2.
I see.
Now I'm going to server 1 and update the value of A to 3. But now the connection between the two nodes is broken. So server 1 cannot talk to server 2.
I see.
At that point, you have to make a choice. You can either say, okay, I can reject the update because I cannot give up consistency, in which case you're not available. Or you can say, I can accept the update, in which case you're not consistent.
Wow, I see. That's a conundrum.
Yeah. Now, you can say, you know what? You can have consistency availability if you give a partition tolerance. But you cannot give a partition tolerance. This is practical impossibility. If you go to any of the big hostels, or even just your average web host, ask them how often they have network glitch that disconnect two machines. In order to get really good partition, to avoid partition tolerance, you have to do something like a cluster.
Right.
A very, very big, expensive machine that is connected via dedicated hardware, stuff like that. Even so, you may get you may still get partitions, but usually you don't.
So where does RavenDB lie? We can see Mongo's here, and Couch is here. They tend to err on the side of availability and partitioning. Looks like Mongo is on the consistency partition, and maybe gives up some availability for that. Where does RavenDB lie?
RavenDB says that you have to that decision is not any of its concern, its own concern. If you want to run RavenDB, then you have to make the decision whether you want for your scenario. Do you need availability? Do you need consistency? I'm not going to make this choice for you.
Wow.
So RavenDB can run in either mode. So a typical example, you can run RavenDB with support for distributed transactions, in which case you get global consistency.
So Raven's right in here.
Not really, because Raven allows you to place it on any node in the triangle. So at any given point in time, you can choose, okay, for my scenario, I want to have global consistency. So I'm going to use DTC, I'm going to do that. If something breaks, my system is not going to be available. This is a choice that I'm going to make. And RavenDB supports that option. If he says, okay, so I'm willing to live with some amount of consistency, because I want that even when things break, I still want to be able to do things like serve requests and answer stuff, and I will handle the potential inconsistency.
I see.
This is when you're talking about things globally. More specifically, RavenDB has two modes for operations, or two levels of consistency that it guarantees. So with RavenDB, you have the notion of documents, and you have the notion of indexes.
Okay.
With documents, think about documents as just a bunch of JSON, just so you can shove into RavenDB. It's just an object graph, and they are fully ACID. So they're ACID in the sense that you get in a relational database. If you give them to me, I flash them to disk, I do all sorts of things. You get consistency. If you have multiple transactions, then one of them going to be, if you have conflicting transactions, one of them is going to say, oops, you try to overwrite on that transaction, so you get kicked out, and you get all of these sort of things. Okay?
So by ACID, just to refresh our viewers' mind, ACID is atomicity, consistency, isolation, and durability. And you're saying that those properties are guaranteed per document in Raven, is what you're saying.
Not per document, per documents.
Oh,
this is actually no. The reason that I'm saying that is that most NoSQL database will only guarantee operation on a single document or a single value. Whereas with RavenDB, you get on a single document, on multiple documents, modifying the same request, on multiple documents modified in multiple requests, on a multiple document modifying multiple requests on multiple servers.
I see.
So
there are let's see if I understand.
Disadvantages of.
Oh, sorry. Yeah. Go ahead.
Yeah, there are advantages and disadvantages of choosing the higher forms of consistency. So multiple requests, multiple servers is something that is prone to failure at some point.
Right.
But again, this is a user choice. We just enable that.
I see. So you can have sort of this ACID model preserved if you choose or not, because I mean there's something that you know about called eventual consistency, which states that eventually everything will be consistent. And so yes. you can choose that or not. And if you decide that you're forcing consistency, you're sacrificing availability perhaps for that.
Yes, you're absolutely right in the general sense. With RavenDB is slightly more complicated or simpler, depending on the point of view. When you save a document, so a document has a key, the ID. So when you save a document, you're guaranteed that all reads for that document will be consistent.
Okay.
That is an absolute guarantee that RavenDB will make for you. But at the same time, RavenDB allows you to store information using any schema. This is a schema-less database. Because of that, what we gain is a very powerful, how do we say that? This is a very powerful a tool. We can store any sort of information in there. But by the same token, how do we get that out? If you just, we can just read, if I can store one object that has first name and last name and one object that has, full name, how do we get the data out again? And the answer to that RavenDB has the notion of indexes. And indexes allows you to say, okay, I want to be able to search on documents that have first name available to them, or things like that. And as you know from relational database, there is a trade-off here between read speed and write speed. With relational database, if you want to be able to query very efficiently, you have to query on an index.
That's right.
But the problem with indexes is that they slow down writes.
That's true also.
So with RavenDB, they don't. All queries are always done on indexes, and indexes never slow writes.
Oh, I see. Is it because the indices are always updating themselves, but they don't need to be completely updated all the way at every transaction?
Yes.
I see.
Yes.
So let's take a step back. Let's take a step back, Ayende. Maybe you can tell us a little bit about what does it mean to be schema-less. And I brought this the RavenDB front page up. Maybe you can talk about what does it mean to be schema-less. Okay.
So in a relational database, before you can start working, you have to define the schema. So if you take a look at the model that we have here, this is the model of a blog. We have things like user, blogs, tags, posts, categories, and comments. And if you sit down and try to write this model in a relational database, we need something like 7 or 9 tables to work with this.
Yeah, it seems like you would.
And you know, you have to sit down and plan for that, and any modification that you want to make is suddenly become much, much harder. And the typical example is what happens if you have, you know, you have to modify a one-to-many association to a many-to-many association. This is a very expensive operation to do in an integration database. And then you have the problem of things like, okay, now how do I keep the schema? How do I keep it synchronized with my application, etc., etc.
Yeah, and there's that impedance mismatch that we've always struggled with since we've started using relational databases. That makes sense.
So with RavenDB and other document databases, you don't have a schema. The database will accept any data that you give it, as long as it's in it is in a JSON format. So these three documents are totally different documents, and they are stored inside RavenDB without any issues. Wow. If we want to go into RavenDB into the user/Ayende and add that title/result, okay, we can do that, and we don't have to now, create a column called title for all the users. So different entities, even if they are of the same type, can be completely different from one another. This is very powerful for two reasons. One is that it makes creating dynamic application where the user can modify things very, very easy.
And I remember that's a common problem. That's a common problem because, for example, I've seen CRM applications where you can define your own sort of properties for a person, and the way to do that was either to throw a bunch of tables at it or to create new columns in the table and sort of overcome that impedance mismatch. You're saying that that's not a problem in this particular case.
Yeah. Yes, absolutely.
That's amazing.
Just to give you some idea, with RavenDB, it would be trivially simple to give Katie's customers different fields than John customers.
Wow.
So Katie always...
Go ahead. Katie always.
So Katie always records, is this a happy person or not? John doesn't care.
I see. So even in between different objects of the same sort of class, I say that in quotes, you can have different properties also for them.
Yes.
That's amazing. Yes. So I say you have a person table. Almost every application that I've seen, business application, has an employee or a person. You're saying that even between different employees or persons, they can have different properties as well. That's amazing. Yes. That's cool. So let's download the thing, and before let me pause because I want to talk about indices first. Okay, so you put those in. How do you get them out? And I guess that's the concept you were talking about indices or indexes. How does that work?
Yes. So the way that it works, RavenDB basically does a whole bunch of. Okay. Did you ever had a system in production that issued unindexed queries to a relational database, and that killed the system?
Yeah. Say that again. I need to understand what you're saying.
Okay. Think about this. In production, did you ever had a system go down because it issued an unindexed query?
Oh yeah. I've seen that before. Yeah.
So you issue an unindexed query, suddenly the entire database decides to go away and think.
Yeah.
And basically, one of the things that we did with RavenDB is to say, you know what? Let's think about all the things that can go wrong and stop them before they can start.
Well, that's nice.
One of the design philosophies of RavenDB is that it is safe by default. So RavenDB does not allow you to issue any unindexed queries. If you want to issue a query, you have to have an index that matches this.
I see.
At the same time, it doesn't force you to create any indexes. So it does a whole bunch of work behind the scenes to make sure that queries are as efficient as possible. So if you issue a query, it will look at the query and says, okay, I'm going to need to read this data. And if you issue the query enough, it will actually create a physical index to match this query. So it's going to self-optimize itself.
Wow.
Based on the actual load of the application.
And also probably
now,
usage.
Yes.
Wow.
So let's say that you have, and this is something that you usually have the DBA to. Just watch the queries coming in. It says, okay, we have a lot of query accessing this part, and so we need some indexes around this place. And usually, literally cannot do that yourself because most of the time you don't really know what is the usage pattern in the application until you actually deploy it to the users. So RavenDB will do this sort of analysis on the fly and fix that.
That is cool.
Now the problem is that you may end up with a lot of indexes. We have a query optimizer in the work that will reduce that, but the reason so we don't want to make indexing part of the same make indexing slow down what you're doing. Slow down writing, slow down transaction operations and stuff like that. So indexing are actually not calculated in the same transaction. Indexing is actually calculated in the background.
I see.
So that means that there is a gap. This is where Raven has eventual consistency.
Got it.
So there is a gap between the time that you save a document and when RavenDB finish indexing that in the background. Wow. Now, this is the important thing is that while it is indexing your stuff, you can still query that. So writers don't wait for readers, and readers don't wait for writers.
I see, and that's probably the biggest difference then, because when you're doing this to a table, as soon as you insert, the index has to be updated before anything else can happen. Mm-hmm. You're saying that let's just go ahead and let it update and let the index sort of get to it when it does. And when it does, that will guarantee eventual consistency. And a good example of this, I think, is Twitter, right? Just because someone issues a tweet doesn't mean everyone will see it exactly at the same time, nor should they, nor does it even matter. And I think that's a very good point that allows a sort of Raven to sort of index these things, but not necessarily at the exact time you insert, which allows you to insert quickly and query quickly.
Yes, and just to give you an idea, we are talking about the indexing gap is measured in milliseconds.
So it's not even that big of a gap.
Yeah.
Wow.
We're not talking 5 minutes or something like that. We talk about literally milliseconds. But by making that statement that you can literally, you don't have to get fully accurate index at the same as part of the same transaction, we have reduced the amount of work that we have to do tremendously. So think about it. Let's say that the database is under heavy load. Well, we already know that we allowed ourselves some leniency in the how often in the indexes. So we can say, okay, we're now under very heavy load. Let's reduce the priority of the indexing so we can accept more read and write requests, and the indexing will continue in the background. It may take longer to execute, but at least we're running.
So in essence, we're just saying, hey, in order to get everything else to work fast, let's go ahead and not ignore it, but sort of put it as a background thing when we're getting high load. We're still guaranteed these other things. We're also guaranteed consistency eventually.
Yeah. So this is an important distinction. For documents, we always guarantee consistency. For indexes, we do not. We ensure we guarantee eventual consistency.
I see.
Okay.
I think that's an important concept. Why don't you state that again? Because I think that's That's probably where the mismatch is in people's brains regarding Raven. I know that was a source of confusion for me. So say that again.
Okay. So when you save a document, you can immediately load that document from from the same server, from another server, doesn't matter, and that document will be consistent. So everyone who reads this document will read the same thing.
Right.
And this behaves in very much the same way as you commit a transaction on a row in the database, and now the moment that you committed the transaction, everyone can see the modification.
And that's
for
if you,
documents,
that's if you, I'm sorry, and that's if you load the document by its ID, right?
Yes.
Okay.
Yes. Now, for indexes, the way that it works is that we give ourselves the freedom to give you a stale result. This is the term that RavenDB uses, a stale result that may not be up to the millisecond, but this is a good enough result. No, maybe it's a few milliseconds behind, maybe it's even a second behind. But for the most part, you don't really care. Think about most of the query that you generate. They're not really that time sensitive, right. Especially not when I talk about milliseconds of delays or even a second of delay.
I see. So
that's perfectly okay to do. Now, another important thing is that while the index is not consistent, the document is. So let's say that you modified a typical example. Okay, so you want to query for all the inactive users, and you just set the user, you just change the user from inactive to active, and you immediately query for, okay, give me all the inactive users immediately after you do this modification. Now, while the index say that this user is inactive, the actual document that you get in the result will be a user that is active. So the data is consistent, even if the query is stale.
Oh, I see. So, I get it. And so so you've changed a person, right? That person belongs to a different index. Even though the index might be stale, the data itself is going to be consistent up to where you've updated it.
Yes.
I see.
Not just up to where you updated, up to the millisecond, up to whatever it is accurate now.
Wow.
So you don't have to worry about getting stale data. Only have to worry that the results from the index may be stale. This is a very, very, very subtle subtle thing. But it basically means that for the most part, you don't really have to worry about stuff like that.
That's pretty cool. So let's see if I can get the subtlety in the distinction. Say you have an index that's looking at active people, right? Somebody 2 milliseconds before changed them to inactive. That person is going to show up in the active query, but when you actually load that person, it will say that they are inactive.
Yes, exactly.
And I think that's an important difference, because even though the index might be stale and think that it is in the active state, even if it's been changed the very instant before you load that object itself, that object is going to be consistent. Even though it's forming part of an index that's stale for that record, the record itself is never going to be stale.
Absolutely.
That makes a lot of sense. That makes sense. All right, so let's play with it. I've gone to the RavenDB.net site, and I'm going to go to download. So do you want me to download the compiled binaries, or?
Let's have fun. Let's do the unstable ones.
Nice. Is that here or down here?
Oh. No, it's down here. Basically, RavenDB have actually 3 different builds. We have the stable one, where we're being very, very conservative what goes. We have the commercial one, which provide even additional level of checks and balances and stuff like that. And we have the unstable one, which is basically whatever is new and shiny today.
Oh, let's do that.
So this is where all the new stuff comes in.
So let me click on it and download it and put it on my desktop. There it is. All right, so we've downloaded it. Let me go to the desktop and find it. It's this one right here. Let me first do the standard thing and unblock it. People always forget to do that.
Yeah,
right, what do we do now?
really annoying. Just extract this.
I'm going to extract it just to the desktop. Wait, let me make sure. Is it a folder in there? No, I'm going to extract it to. I'm going to go ahead and extract it then. Right here. Okay, it's open.
And okay, now the installation is somewhat complex.
Okay.
Go to server.
Okay, server.
Double click on the Raven server exec.
Okay.
We're done.
Holy cow, that was so hard. That's amazing.
Yeah, so you probably need to authorize it. No.
Already did.
We're done. Yes. Okay.
So how do I access this?
Go to localhost.
Oh, you're
localhost
kidding.
8080.
Wow, localhost. Look at that. It's right there.
Yeah. So now you have your own RavenDB server running.
That is amazingly quick. Is there a Windows Service version of this, or can you?
Yes. So if you want to run it, you know what? Let's run it as a Windows service.
Let's do it.
Okay. Open the command line. Shut this down. Just hit enter. Oh, just shut it.
Okay.
I don't want to do it.
Okay, and let me run the command. Okay.
Go to the server directory.
Okay. Let's go to this.
Now cd server. And now raven.server.
Okay.
/ install.
Yes. And that's it, huh?
Yeah. So now again, go to localhost 8080.
Wow, there it is. Let's see it actually running in the computer. So let me go to manage here. And we should be able to see in the services Raven running. LMNOP. There it is. That's pretty cool.
Yeah.
All right.
I certainly think so.
I do too. All right. So there you go. It's running. Where do you want to go from here?
Let's do some real work with this.
Okay.
So let's open Visual Studio and create a new project.
So we're going to say File New. I'm just going to do a Windows Forms project because it's something that's probably I'm most familiar with. So
sure.
Raven test. Okay. Now, are there any assemblies that I need to add in order to get something to save? Okay.
Yes. So let's add a reference.
And it's probably going to be on my desktop. Is that right?
Mm-hmm.
Okay.
Go to the client. Just add all three.
Okay.
Now let's go to the program CS.
Okay.
And okay, in here we want to do raven.client. New raven.client. Document store. 1 second. So I don't really think about namespaces that much.
What's it called? I'll just
So Raven.client.document store.
let me just do this. So new document store, right?
Yeah.
Okay.
Okay. And there is a property here that you need to set, which is the URL.
What is it?
URL.
Okay. Oh, and it's going to be obviously
localhost 8080.
Got it. That makes perfect sense. Because it's got to know what it's pointed at, right?
Mm-hmm. And now we need to initialize it. So doc.initialize.
That was too many. Okay.
Yeah.
And that's it.
Okay, now we're done. Yeah. So now we initialize the document store. When we're working with RavenDB, we're working with a session.
I see.
And we get a session from the document store. So in this case, what we can do is just call. I'm trying to think of where do we want to. So we probably want to do the actual actions in the form.
That's right.
So we need to. So we. Yeah.
Okay. And let's go there.
And.
Okay.
Okay. Give it a property that it have a document store property.
And it's going to be a document store, right?
Yeah. iDocument store, same thing.
Oops. I pushed the wrong thing. Document store. Got it. Okay.
Okay. In the program CS, we need to set the document store property.
In the program CS?
Yes.
I see.
We create a new form there, and we need to set the.
And that's going to be obviously this right
here. And
okay, got it.
Wonderful. Now we want to do something with this. So what do we want to do?
Let's make some classes, right?
Mm-hmm.
Add a class. And what do we want to do? Let's something simple.
Yeah, let's do, I don't know, an account.
Okay. And let's give it some fields. What kind of fields should we give it? A name?
Yes.
What else?
Establish it.
Okay. So we're going to do... Incidentally, when you see me write this code really fast, it's Code Rush that's helping me do it fast.
Yeah, I noticed.
Because I don't like typing these things out.
Yeah. One thing I like very much is that this is the killer feature of Code Rush for me, is that it has these thingies here, the number of lines in the method, or the cyclomatic complexity of the method.
Yeah.
It's something that I really, really, really love.
Yeah, I do too, because all of a sudden you can sort of tell whether a function needs to be broken apart or not, just looking at those couple of methods, right?
I know, it's not even that important. I just really, really like to see this.
Oh, cool.
Just look at a glance. Oh, this is 20 lines. Maybe I need to do something about that. Okay, established. Let's do something a bit more interesting. Say owners.
Okay, owners.
So yes. So that would be a list of string.
Okay. So let's see if I can do a collection of strings. I don't know that one. Hold on, let me see if I can remember the Code Rush. Collection. No, A. Incidentally, if you don't know how to do something, literally it teaches you. So we're going to do a collection of strings. So we're going to do AC dot string and then space. I think it's string. Yep. Boom. What are we going to call it? Owners?
Yes.
Okay.
And do you want to do something else?
Let's do this for now and see what happens. Because later what I want to do is that instead of having a collection of string owners, let's have a collection of person owners and see what that does. But let's start with this.
Okay. Yeah. So now what you want to do is actually save some stuff to the database.
Okay, so let's do that. Let's add a button here. Here it is. And we're going to click it, and we're going to save an item. Okay, so let's create a new account. Account, and we'll just pre-fill it in here. So we want to do established. Now, and then we're going to do name account, and then we're going to say owners equals new. We can do collection. Let me do a new list. String, and then we're going to say
Ayende and Steve and Seth and
Steve and Seth. All right, will that even work? Does it like this?
No, you have to go to account, please.
I have to go to where?
Go to account. You said you made the owners a collection.
That's right. Let's do list.
Probably want to make it yeah. Oh, I collection, same thing.
I collection works too. Good. Yeah. So RavenDB is okay with using abstract stuff when it puts it away.
Yes.
Oh.
Or you could use concrete stuff. Doesn't matter.
Okay, so let's save it. So obviously we have to use a document store, right?
Yes. Now we want to create a new session. Okay. So you call open session.
Okay.
And this wrap it in a using statement.
Okay. Okay.
And I will let you figure now. Now I'm going to do a user study.
Okay.
Figure yourself how to save this to the database.
I'm going to say session.save. Wait, you got to add something to it, I'm guessing. So let's take a look here. No. There you go. We're going to store something. Let's do that. And then we're going to do session.save changes. Does that work?
Yeah.
Perfect.
That is how it's supposed to do. Do this session dot again, please.
Okay.
If you notice, you will see that the session only exposes 6 methods, which is delete, include, load, query, store, and save changes. That's it.
So you can
now
you can in essence add a bunch of things to do to the session and then just hit save changes.
Yes. And it's actually very important because what you see here is actually a very, very simple API. So you have never seen this before. Listeners, this is the first time you've actually looked at the API.
That is correct.
And it took you what? 10 seconds to figure out what to do?
Yeah, and I'm slow. So
okay. Now there are a lot more operations that you may want to do, a lot of advanced operations. Where do you think those advanced operations are? Go up.
Oh, there you go. That is amazing. Yeah. And so what you've done is you've tried to think of hey, let's think of the developer here when writing this API, so that in essence the documentation for the code is the code itself because it's discoverable in such an easy way. I got it.
Yeah. So the main idea is that CRUD is the main stuff that you want to do. So let's make CRUD front and center. There are all sorts of capabilities that you really want to be able to have. They are important, but you only use them, 1% of the time.
Right.
They shouldn't be in your face all the time. So we stuck them all in the advanced stuff.
That's clever.
And there are even more advanced stuff that you may want to do, and they are not even in the session. There are other places that we have this API available for.
That is cool. I like it. All right, let's test it out and see what happens. So no need for a breakpoint. Well, maybe I'll just do one just for kicks and giggles. So I'll hit the button here. We get to the session. We open the session. We store it, save the changes, and there we go. We should be able to see it in our database, right?
Yes.
So let's go to Documents, and look, there it is.
And open that, please.
Just click it, right? There you go.
Yeah.
That is amazing.
And there you see the document.
Okay, so let's test your theory out, and let's screw around with the API a little bit and see what happens. So we're going to add a public. We're going to add a public description. Right? And what we're going to do is now we're going to save a new object, right? But we're going to add a description and see what happens. Okay. Now we're going to hit play. And let's hit the button. F10, F10, F10. Let's go over here and hit the F5 button. There it is. It did not have a problem with that at all. In fact, you see description here, but it's not here. That is cool.
Now let's do something even more interesting. You see that the first one is account/1. Now, what happens if you load account/1 when you have a missing property?
Oh, let me go back. Account/1. Yeah, because it doesn't have the description. This one does. Let's see if it gets upset when you try to load it. So let me add another button. Let me add another button to the form. Okay, so simple button. And we're going to say load. Okay. And okay, so we're going to definitely do this again. But instead of store, we're going to say .load. And we're loading an account, right? You probably don't need this, but I'm going to do it anyways. Then I'm going to say the ID is 1, right?
No. The ID is string, and the ID is account/1.
Oh, there you go. Account. Oh, I see. So these things have like their a URI kind of approach.
Yes, and it's not account. It's account with an S. Accounts.
Okay. So var account equals this.
Okay. Wait. Let's do something even cooler. Keep the save changes.
Okay.
And now put a breakpoint on the save changes line.
Got it.
And let's see what's going to happen.
All right, so we're loading the old one. Let's see what happens. Hey, it's happy. It just puts a null in there because it didn't have anything to put in there.
Now, go to the description and modify it, please.
Got it. So let me do a quick edit, a quick watch here. Let me bring this over. And let's change the description here to something useful. So
let's change the name as well.
Let's change the name to. Oh, I needed to put in the strings.
Yeah.
And let's go to the Okay, looks like we have 3 owners. I wonder if we can't add owners. It's too bad. There's no ellipsis here, but I would. Let's hit close. Okay, so now account is a little bit different, right? So let's
now hit F5.
F5. Let's go back and see what happened.
Go to the database. Yeah.
Okay. There it is. Yeah, it looks like it had no problem sort of fixing, quote, itself.
Now, go back to the API and tell me, where did you tell RavenDB that you actually wanted to save those changes?
Oh, that's right.
We didn't call session.store again.
No, we didn't. So
what actually happens is that when you load an entity via the session API, it actually keeps tracks of all the changes that happen to this entity.
Wow.
And because of that, when you call save changes, it goes and look on all the changes that were made, even the implicit changes. So you loaded the account, you modified the account, and then you call save changes.
Right.
So obviously what you want to happen is that this should go into the database again. You don't want to have to do manual change tracking.
So does it keep track? So you're saying it keeps track of any changes that were made to the object? What if I made no changes? Save changes would have done nothing. Is that right?
Yes.
I see.
Yes.
I see. Well, cool. All right, let's make a new class and make this iCollection of owners something a little bit different. So we're gonna do a new class and we're gonna call it an owner, right? And we're going to say that an owner, right, has a name. Also, an owner has a, I don't know, address and has a description.
Wait, let's make it more a bit more complicated. Make address a complex object as well.
Okay, so we're going to do address here. Right, and what we're going to do is we're going to add a class for it. Very good. And an address is going to have a
street number.
Street. Oh, what did I do? Hold on. I hit insert.
Yeah, really annoying.
Street. And then city, state, zip, and country. Okay. Very good. Okay, now let's add owner also needs to have, I don't know. Anything else we should add for an owner?
No, I think that's good.
All right, so let's do an iCollection here of owner. And now
let's change the collection to list of owner.
Okay.
To make things simple, it would make things simpler for us later on.
Okay. So let's do. Now this is obviously not going to work. Well, actually, it will work. No, well, we have to change.
Wait a second. Let's comment this method.
Okay.
Or comment just line 30.
Okay, let's comment out line 30. Okay.
And now let's try to load it again. And this time, let's try to load something that has drastically changed.
Okay, so I'm going to save this again, is what you're saying?
No, we want to actually load it again.
Oh, so that would be over here.
Yes.
Okay, so let's load it up. Oh, I see. Because we've completely sort of obliterated the object model to something that's completely different. Obviously, there's a graph of objects now, not just a list of strings. And so you're saying that it's going to be okay if I load it this way. So let's see what happens.
I don't know.
All right, let's see here. Oh, I hit the wrong thing. I meant to hit. Uh-oh.
No. Okay. So this is a big scary exception, but basically what it means is that, sorry, there is no way to reconcile automatically the account and the data that there is in the database.
Right.
So this is a non-compatible change. Compatible change would be something like add a property, remove a property, stuff like that.
I see.
Those are handled automatically. But if you change the type of a property, well, if you try to put a string into a data, this is obviously not going to work.
That's right.
So that is something that you have to be aware of, but for the most part, this doesn't really happen.
No.
So let's just go to the database and delete those items.
Okay. So we're going to the items and we're just going to delete the old ones? Is that what you're saying? Okay, so let me, how do you delete them? Oh, there it is, the big button that has a delete on it.
Yeah. Okay. You need to authenticate as your local user.
Okay.
By default, RavenDB will not allow you to modify stuff unless you're logged in.
I see. What the heck is my username? That's embarrassing. Hold on, I know how to log. It's Seth. Okay, so it's Seth. And then my password, ABC123. That's a joke.
Yeah. Now delete the second one.
Okay, now F5.
Hit F5.
What is this?
Okay. Note, this is how it generates the numbers for the account.
Got it.
So if you notice that we have every time that you, this is the primary key generator.
Okay, got
That's
it.
the easiest way to explain that.
Perfect. All right, so let's go ahead and save some documents now. Okay, so we're going to do new account, and we're going to say owners equal new list of owner. And we are going to add some new things. So we're going to new owner, name Seth, and address equals new address. And we're going to say city is, we're in Glendale. And country, US. And I think that's it. And we're going to say new owner here. Name equals Ayende. Address equals new address. City equals, what city should I put for you?
Hadera. Hadera.
And country, Israel. Okay. And there you go. So notice that we have, what we've done is we've created an object graph that's an account that has a list of owners that has an address. That's a sub object, and we're going to save it. All right, so let's hit play. Let's save it. And let's take a look at what we've got here. I see, and so there is the ID you were talking about. Where's the ID here? 2049. And there is the whole object graph. That's cool. All right, so let's load it up and see what happens.
Think about, wait a second. Look at this document and consider how many tables you would have to have it when you're using a relational database.
At least 3.
Okay, and how many queries would you need, or how many joins, in order to load all of the information that you see right here? 3.
You need to join the account with the actual owner with the actual address.
Now the fun part is that with RavenDB, loading the account is a single operation. This is also a very cheap operation.
That's cool. I like that. Let me load it up and see what happens. Let me load it up, make some changes.
Yeah, sure.
So we have the account, and this is 2049 now, right? And we're going to say account dot owners, and we're going to do the first one, which is me. Dot address.
Second one.
Oh, that's right. Jeez, I just went. Sorry, everyone. This is embarrassing. I just reverted to VB6. That's embarrassing. Don't tell anyone, okay? And we're going to change the zip code to, is that a string? I don't remember what I called it. Yes, I did. 5. And we're going to change the zip code of the second one. 1, 2, 3, 4, 5. And let's do one more change. Established. Oh, we already did that one. I want to go to the owners. Zero dot name equals BB6 guy. All right, let's see what happens here. So we're going to hit the load. We've made the change here and here. We're going to save the changes F5, and let's go back and see what's happened here. Look at that. It indeed is happy with this. This is great. This is great.
Yeah. So now let's try to do something else. Okay. Let me think for a second. Let's do a query.
Good. I like that.
Okay.
I need to move
so
my
let's
button.
hit a new button.
Let's add a button here. Okay. Okay. So I've added a new query button, and let's see if I can figure this out. So I know we have to use a session. That seems to be the right thing. And you said that the standard things are going to be off the session object. So.
Yes.
So let's see. Delete, no. Include, no. Query, right? So let's take a look at this query object. It looks like it's an iQueryable, so that you can use LINQ. Okay. So var q equals from accounts in session dot query of accounts, right? Which is a function. We are going to say where a dot name equals, and let's get the account name here to see if it works. Account select a. And what I'm going to do is I'm going to say var results equals q.to array. Does this look right?
Yep.
All right.
Now let's try and see what happens.
Let's see what happens here. Oh, let me put a breakpoint here just to make sure, because demos are not cool unless we have breakpoints. So let's hit this. There we go. It's right in there. Let's take a look at it and see if it's the right object.
Well, it has to be the right object. It's only one.
Well, duh. There you go. I like it. That's cool.
But let's try to do it a bit more complex.
Okay.
Let's look at the owners.
Okay.
I want go up and look at the data that we have here.
Okay.
So we have an owner whose name is what?
Seth and Ayende.
Okay. No, Seth is no longer there because we changed it to VB6 guy.
That's right.
So I want to find all the accounts where the owner name is Ayende.
Got it. Okay. So let me see if I can just do that myself. Where a dot owners. Can I do a contains here?
No, it's use any.
Ah, I see. And we want to, it's any of owner, right?
No, just any.
And we want to do
automatically detect that.
O dot name equal Ayende.
Yep.
Excellent. So this is saying, in essence, we're going to select the account where any of the owners is Ayende.
Yes.
10. And there it is. Let's add a new one. My other account. And let's change this to Jack and Jill. And this is going to be simple button 1, which is that top one. So we'll click that and add it. F5. It's happy. Now let's query a little bit differently and find where there is a Jill. Right, because this is actually going to do something interesting because we've added a new document.
Yeah.
So there's 2. One with myself and you, and one with Jack and Jill. So let's go ahead and hit F5 and do the query. F10. Yep, there it is. And the owner indeed has Jack and Jill. That's awesome.
Yeah. So the important thing is that we just ran some queries, right?
Yeah.
And if you did it in a relational database, what sort of query this would be?
Well, you'd have to join. You'd have to do a join. It would have to search across the join index. It would be more complicated, obviously.
And more to the point, it would be an unindexed query.
Oh,
RavenDB does not allow unindexed queries. So what's going on?
It's creating an index on the name of owners. Hold on.
Yeah.
Let's see if it's there. I remember seeing it indexes. Holy cow! Look at that.
So by owner's name. So look at the LINQ query that you have here. You can literally read that. Oh, just click on the.
Wow.
That.
So
you can literally see how it works.
Yeah. So this is like saying, okay, what we're going to do is we're going to make an index, but let me tell you exactly how to get there. I see. What is this reduce thing?
This is for next episode.
Okay, so that's a in the future. Okay, got it.
Yeah.
That's awesome. So every time I make a query, because there's no such thing as a query in Raven unless there's an index, it's going to make an index for me and let me just use that.
Yeah. Now, notice that this is a temporary index.
I see.
Now, if you try to run, let's cheat, okay?
Okay.
Go to the query and query that index 1,000 times.
This one?
Go back to the code. No, go back to the code.
Okay, got it. And do
and
while?
Just wrap the entire, yeah. Just for loop 4,000 times.
Okay. And run it.
Yes. So
I'm not going to break
just
through
hit F5. Yeah.
I keep hitting the wrong F5. Let me hit.
Oh, yeah. No. That's okay. Notice what you get. Okay. You made too many queries in a single session. This is usually an indication that you're doing something stupid, like making 4,000 queries to the database.
Oh, so you're protecting me. This is good.
Yeah.
Because like I said, all of us coders write our best code between 3 and 4 a.m. And the problem is that sometimes between 3 and 4 a.m. we do dumb things like this.
Yeah. So there is a way out of that. So stop that.
Okay.
And call session.advanced.max something. Yeah. Just make it 5,000.
Holy cow. And true to form, this is not something you would usually do. So it's an advanced, as you said before. So let's run it again.
Yeah.
And query. He's thinking.
It's usually going to take about 10 seconds to issue 4,000 queries.
And even if it doesn't, I will make it look like it does. Okay, good. There it is.
No, it does.
Yeah.
It does. Yeah. So a 5.
Okay.
We don't care about that. And let's go to the server again. Read a 5. Notice that these have changed from temp to auto. So now this is a permanent index.
Wow. But that's been auto-created.
Yes. So RavenDB have noticed, look, you're making tons of queries on the owner name. So this is probably a very important query.
Wow.
So let's make it a permanent index and keep updating all the time.
That is
if
amazing.
we haven't done that, so if you just go away from the computer for 10 or 20 minutes and come back, you will see that the accounts by name index have gone away. It's no longer important. It's not being queried. So we're just going to reclaim that.
I see. That is cool stuff, man.
Yeah, I certainly think so.
Wow. So what we've done then is we've shown how to use Raven in the simple sort of CRUD fashion. Additionally, we've looked at how RavenDB sort of adapts to the queries that we make. We've also seen how it adapts to class changes. Obviously, there are breaking changes also that you can make when storing objects, which makes perfect sense. That's pretty cool. So now here's the last thing I want to talk about, because it's something that's maybe a bit of a confusion. When do I, for example, store an account as its own document versus an owner as its own document? Notice that they're all part of the object graph. So as I'm looking at the documents, I see that they form part. When do I make an object its own document?
When they exist in a different transactional boundary. So typical example is that account would be, or let's talk about the typical online shop. You have the notion of a customer, and customer is its own transactional boundary. And then you have an order. Again, its own transaction boundary. An order line is something different altogether. An order line is a part of the order, so it be embedded inside the order.
Got it.
But customer and order are two different things. They exist. They have separate existence, so they would be separate documents.
I see. So you're saying if an object can sort of exist on its own or live in its own transaction boundary, meaning you can operate it by itself and it makes sense, it should be its own document.
Yes.
I see. So the reason why you're saying that a customer versus an order are two different things, because an order can live independent of a customer. And I know that doesn't make sense, but an order can have, for example, say I buy something for someone else. That order sort of lives on its own because it's for someone else, but a customer is a different thing.
This is way of looking at that. He said, if I want to modify an order, I don't need to modify the customer, and vice versa. It's just two totally separate things, and the lifetime is not the same thing. But the lifetime of an order and order lines are very intrinsically connected to one another.
I see. That makes sense. Because an order really exists only because there's items in the order. That makes sense. That makes sense. All right, so we've looked at a couple of cool things, but Ayende, I am interested in seeing this work in real life in a real application. Would you be interested in maybe doing a couple of more sessions where we actually make something?
Oh, yes, of course. Of course.
That is cool. Well, let me just tell everybody, one of the things at DevExpress that we're interested in is working with multiple data providers, and I think Raven is probably one of the more exciting ones. Please stay tuned, where Ayende and I are going to make some applications. And anything you want to make, Ayende, in with this series?
I have the notion of building an application that can really take advantage on the dynamic nature of RavenDB. So something that is almost completely dynamic application.
I like that.
And yeah, so we'll talk offline, and then we come back and we'll try to really blow people's head off.
Well, thank you so much, Ayende, for spending the time. Everyone, download Raven, play with it. It's a very, very, very interesting way to store things and to load things, and it seems like it also has a brain of its own. So I'm pretty excited to start playing with it. Thank you for watching, and thank you for choosing DevExpress.